Hello everyone, this is another episode of On.NET, a show where we talk about all things .NET with the team and guests. And today we have Jeremy. Hi Jeremy.
Hi.
And we're going to talk about long path support in .NET, which is a thorny subject, isn't it?
Yeah, well, it's an old problem, and it's been around for a while.
So why don't you tell us a little bit about yourself and what you're working on, and then maybe we can start diving into the history of that problem.
I've been at Microsoft for a long time, almost 20 years. The past year or so, I've been on the .NET team, and one of the big things I've been working on is long path support. Specifically starting in CoreFX and then doing some work in the desktop as well, 4.6.2. So continuing to work on that sort of stuff, but our system I/O related things primarily.
Cool. So why do we have this problem in the first place?
The long path problem's been around for quite some time. As you know, it's a max path issue. So Windows historically has supported paths up to 260 characters, or the max path defined, as most people are aware of. Going back 30 years or whatever, that used to be a pretty reasonable amount of characters that you could use. Most people had taken that and actually defined their native applications around that max path define. It's been baked into a ton of things, including .NET, for a long time. And getting around it's been a pretty difficult challenge to get the wherewithal and actually be able to make the steps to move beyond that. So a number of things have changed. One, of course, time has gone by. So a lot of the old things have fallen off of the supported matrix. So, what the story was when .NET originated, 15 years ago or whatever, has obviously changed. So that's made things easier. And of course, now we have .NET Core. So going open source, going cross-platform also changes the picture a little bit as well. So.
Backtracking a little bit here, so I can actually create deep folder structures in Windows, and I will not see a problem until I try to use those paths in application, right? So
correct.
What exactly is the problem in Windows? Where do you start seeing the problem?
The problem is in using paths as in the old traditional syntax, the C:\\, whatever. Most of the Windows APIs, and I talk about this in my blog in some detail to help clarify how this stuff works, because it's also very confusing, the reasons for that, and there have been workarounds as well, and some people know that as extended syntax, or it's a DOS device syntax. It's where you do a \\, \, in front of your paths. That allows you to get around this particular thing. But basically what happens is that, there's a check in Windows that looks for this max path thing as a compatibility thing. And if your paths are longer than that, then that throws. The exception is that extended path thing that I spoke about. And that allows it to skip that check. But it also skips normalization as well. So it has another side effect. It's actually the equivalent of the \\, period, / prefix that you put in front of your paths, with the added change that it actually skips normalization and skips the max path check. So that path syntax, however, was also not supported in .NET, right? The \\ thing. So even if you did go and create those paths using the extended syntax on Windows, .NET wouldn't be able to handle those, because you couldn't use that path. In Core, .NET Core, so Core FX, we've done the work of putting the question mark syntax on things for you when we call the Win32 APIs. So that means that you'll be able to use paths without thinking about that syntax at all when you're using .NET Core, and it will just work, right? So.
Okay, so that makes sense. But you just said earlier that disables normalization of the passes. So
correct. So like what happens here, like, and this is where we have some control in the framework, is that we do the normalization first. One of the lucky coincidences is that the normalization API in Windows, or get full path name is what it's called. That API has always supported long paths, or at least on any NT operating system that we support.
I see. So you normalize first, and then add the prefix, and then you're fine.
Correct.
And we're doing all that for you. So yes, you can just use system.io as usual. It will just stop blowing up, and that's it.
Yeah, and that was all of the .NET APIs that you use around I/O always went into normalization. They called the path get full path essentially, right. Anyway. So that was our basically, to do that and make it work seamlessly as far as going down level and working on all the supported Windows platforms. Out of those particular platforms, there's like I said, it's, as far as I know, it goes back beyond Windows XP, which we support, Vista at this point, and the 9x things don't matter anymore at this point either. But that was one point where it didn't. So I believe that answers your question on that one.
Yeah.
So the thing that happens that most people don't realize is that, like, whenever you call a Windows API, it internally calls essentially get full path name. So that's another thing that comes into play with this as well, and this in the decisions and the design around what we've done. So you're not really losing anything or like being forced down anything, because .NET actually does the normalization. It actually ends up being kind of a double step, because anytime you call something to Windows anyway, it's still going to go through the same method again, with the exception, of course, is if you use the question mark syntax, which lets you skip that. So there is kind of, in that case, there is a little bit of a perf benefit. Unfortunately, there's also a perf downside in that, like, we have to allocate another string to do that, but we only do that if we actually end up going over the legacy limit of max path. And as part of that, the old normalization APIs that we had inside of .NET weren't really designed to deal with long paths, right? So they were all highly tuned to the 260 character limit. Had to go through and rewrite that, because now paths can be up to the size of what essentially is a Windows string internally, and that's 32,000 characters roughly. So that's obviously a huge difference from 260. And we were allocating on the stack, for example, to deal with going back and forth to Windows, and you really don't want to do that, obviously. Once you start going beyond 260 characters, that starts getting pretty crazy. You get two paths and you're like run out of stack space, right? So that we had to go through and do that. As part of that, we also have changed, going through it with a fine-tooth comb to make sure that this was all correct, and then the performance was all there. We also made the updates to the normalization that we did in .NET to fix some of the issues that we had before. We used to, for example, actually try and do some of what Windows would do up front. The problem with that is that it's somewhat redundant. And number two, it's really hard to get correct. And we weren't exactly correct. So there were some places where we differed from what Windows would do. So like there were paths that you could create without the question mark syntax that would actually be doable, like in the command prompt, but you could not do or utilize in .NET. One simple example of this is you could create a directory with a space on the end of it, and that would cause .NET to choke on that because it didn't think it was a valid path. So it would take it out. So you could walk through a directory and you'd get back in subdirectory that had a space on the end. We'd normalize that space away and we'd never be able to find it, that sort of stuff. So that was one of the big design changes. We talked about it in some design stuff last year that was public for .NET Core, but we try to defer to the OS. We let it be the one that like determines correctness, right? So with some minor exceptions, we had a few tweaks that like we did to try and keep things somewhat compatible with people's expected behaviors. Stuff with like trimming of spaces and things like that on the end of the path. Windows itself will only trim spaces. .NET has historically trimmed all white space, so we continue to do that just to not be too surprising for existing applications and users.
So you mentioned some timelines here about those changes, so that people can know what to expect. So .NET Core, that's already in the RC2, right?
Yes. So that's there. It's been there since last fall. The runtime has been updated as well to support long paths. So that's all ready to go, and everybody should be able to play with it on RC2, or once we release that, it's good to go.
On .NET Framework, you said 4.6.2.
Yes, in 4.6.2, we've started to pull some of this functionality back. The desktop framework is a much more complicated space to be working in because it goes beyond just like what we've put out in the open source things. You have things like WPF and all the other supported libraries and pieces. And we had already gone through the exercise for CoreFX and to centralize where we called the operating system as part of doing the cross-platform work. So doing some of these things was a bit easier to do in .NET Core. The place where we've started is that this normalization behavior, the changes that I've talked about, have come back to 4.6.2. So you get the ability to access the paths that you were blocked before. There's some performance improvements that are part of this. And in some cases, you can actually utilize the extended path syntax now. So that allows you to get at these, both the extended path syntax in general, but that provides long paths via that mechanism. But it also allows you to access paths that are not normalized. So one example, there are some things that get, when you normalize a path, the rules are really complicated, and I talk about it in my blog somewhat. But the one example of something that gets normally normalized away by Windows is if you have a trailing period on a file name or directory name, a single one. So, I mean, the rules are very, very complicated, but as part of POSIX compliance and all this sort of thing, they allow, the underlying file system allows you to do this, and the question mark syntax allows you to get to that and do that. And before you would be blocked on those sorts of things, and there was no way for you to get a hold of those. Another thing about the change of behavior, and this is kind of an important one too, is that when you use these, they're called DOS device paths, right? The \\/ question mark or the \\/ period thing. That in particular, we don't do all the checks that we used to do for paths in general. So notably, one of the things that we don't do is we don't check for what we consider to be invalid characters. So this was another thing that was causing people to be blocked, because you can access different sorts of things this way. Like one notable thing would be pipes, right? Which you still open as a file, right? And you use the create file API in Windows to get a hold of these things, and it goes through the same set of .NET APIs and System.io. But it accepts all sorts of characters that you can't use in a regular path when you name a pipe. So even on my own machine, you know, I have NVIDIA creates a pipe that like you just can't open in .NET, right? Because of the name that they used as a character that's not normal for a a regular disk path, right? So again, that's part of the philosophy now too, is like we let Windows deal with it, right? We let the OS tell us if something is bad rather than try and do all the guessing up front. I said it was limited because people that have been following along with this may have noticed, there were a lot of blog posts by Kim Hamilton in the past who was looking at some of these problems before too. One of the things that was a blocker before was trying to get around file IO permissions. Like in order to deal with limited trust scenarios on the desktop, we needed to like allow people to be specific about allowing or not allowing very specific paths or sets of paths, right? And trying to rationalize how you dealt with that, in the existing file IO permissions, having multiple versions of a path or paths that couldn't be like only really represented in the extended syntax was a difficult thing to do. For now, what we've done to unblock things and move things forward is basically in MS Core Lib specifically, which is most everything, right, with System.io. If you're running in full trust, the file IO permissions, which essentially become a no-op anyway, will allow that extended syntax. And it's about 95% of anything you see in System.io. There are a few exceptions to that, and continuing to work on trying to hunt those down for future versions of .NET beyond 4.6.2.
Okay.
So you'll get that. So there's this sort of functionality you get all over the place. But the other thing this enables, of course, is the ability for using long paths should Windows actually ever remove that max path limitation. So.
Yeah, I was actually going to ask about work that's happening on Windows itself. What is going to change on Windows?
Well, some people have noticed that they've been experimenting with it. So they're definitely working on the problem. They haven't made any commitments to it. But as to like timing, as far as when they're actually going to release that. But in the latest Redstone builds or the anniversary update, fast track builds and stuff, they have been utilizing or trying some of this stuff out. So they haven't talked about exactly how to turn it on, but people have seen that there's some new policies and the like that are related to this stuff. Mm. So once they've gotten to the point where they actually talk about that and release that publicly and whatever else, .NET will be ready to go. And that's actually been one of the big problems that we've had with the whole long path thing in general, right? Is that, .NET's been popular, which is great. But it's been so popular, it's become integral to almost every workflow, right? It's very rare that you don't have .NET involved in some way, right? In anybody's workflow, any application, you have .NET coming up somewhere or some .NET component, right, or managed component. And even if Windows did remove that limit, right, you'd still have .NET falling over, right? So, .NET is kind of almost a precursor to having Windows support, right? If .NET doesn't do it, you're not going to get very far with Windows removing that check. So,
Is there any work that had to be done actually to were there any limitations in .NET previous to that work that were actually affecting other OSs than Windows? Were we doing some checks that were actually degrading stuff on other systems than Windows?
Yeah, I mean, that was one of the things that helped drive this. Like the 260 thing was baked in, right? And the runtime too as well. And, obviously that's not something people expect on Linux. So
yeah, we are basically exporting some Windows specific problems onto Linux.
Correct. So this is one of the things that helped push the problem forward. It was a confluence of all these things, right? I actually came to the .NET team because of this problem. I looked at the long path thing's been a thorn in my side for many, many years. So, I worked on build and project system stuff. I worked on the expression suite and blend and these sorts of things. And it was you hit it all the time. You always like fighting over every last character and paths to like try and make sure that you keep things down, that you don't break that many people, right? When they go and create their projects or
260 is not a lot.
No, not particularly when you start taking like engineering systems and things into play, or like the developer scenarios, right? So, you got a shadow cache, right? And like, we need to make sure that we have a separate, folder for every version, and that like we keep things, for you have multiple iterations running at the same time. Like you have, the folders aren't going to collide. And like, whoops, we ran out of space again. Like, all right, what's another creative way we can come to like squish this down, and still like utilize the temp folder, right? There are all sorts of crazy tricks that Windows even itself has done, over the years to try and mitigate this. That was actually a big driver in like the rename. You remember like on Windows, you used to have My Documents and everything was my whatever, right? The paths were like really kind of long. It was one of the big arguments to push that down to like users, right? Instead of what it used to be, because that was a problem. People were running across the long path thing. The shell has some functionality, and people have seen this too, like where it will try and create the 8.3 file name version of things for you, right? If the path is too long, right? So you can see this if you like create a folder that's longer a bit than the max path thing, and you navigate to it, and you have to be really do some finesse to get to it. But like you go and select it on the file explorer, and instead of getting the normal path, you get the tilde version of the path, right? And that was another mitigation thing that the shell tried to do, and so on and so forth. They're all very, very aware of it. I spent a lot of time talking to various Windows teams last year, and as people have noticed, they are definitely working on the problem. But not being a Windows guy myself, I'm not really the person to reveal exactly what they're doing in their time frame. So
sure,
I'll leave that to them.
Do you have a demo of the new stuff? Or?
I have let me see if I can get this thing to work without kicking feedback in. I'm going to try and join it over here. And I have a machine with I believe it's the latest. I haven't checked like today or anything, but the latest fast ring. All right. I believe I'm muted. Maybe.
Okay.
All right. No, jeez. How do you mute it?
So your second stream is muted actually already, so it should be good. I just
Right.
switched it, so you just have to share on that
Right.
screen, and
Good.
should be good.
Sorry, I'm trying to get it to actually do something when I click the screen share. Well, I hadn't actually tried it on the latest. Well, I suppose I can share it over on this one. I have it on my other screen, but
Okay.
I'll drop that one.
I guess I will do some light editing of the file.
I did.
Okay.
So one thing is just to show you, and again, I talk about this in my blog, and we can add some links to these things so people can read up on this a bit.
Yep.
But when you actually utilize a path, what you're getting at here is this is a WinObj, and it's a sysinternals tool. There's no way to scale the size on this, but in here you'll see a C colon.
Yeah.
And when you pass a path to Windows, when it normalizes, it looks at it and tries to see, well, is it relative? Do I need to put the current working directory or the last working directory for the drive that you're talking about or whatever onto the thing? It does that. That's one step that happens. But after that, it then translates it so that it can get to be a Windows path, or for the object manager to then take it from there. And it finds those, and everything that shows up in Win32 is the stuff that's here in this. It says global ? It used to be just ? And that's why they're using ? for the backslash thing. Over the years, they added multiple users, so global's on there. That means for global users. Then there's actually a one for each session, where if you do a mapping for a network drive or something like that, that's where it looks first, and then it comes into here. Because I haven't mapped any network drives on this one, it's all it's just coming to the main folder here. But C : foo will come here to C, and that's a symbolic link to device hard disk volume 3, right? So that actually becomes the path. And if you look at the rest of it, we have device, and in here will be hard disk volume 3. And this is the actual device.
Yeah.
It gets handed off by the object manager to the file system stuff, and then the file system then takes it and parses the rest of the path, creates the object, and then it gets passed back. So if you take the actual handle that you get back and ask it for the path, you'll have the backslash device, the hard disk volume 3, foo, if that was what you were looking for, right? Instead of C : backslash. And this is why because of this translation, this is why the limit around the long pass has always been about 32,000, because it has to be translated to whatever the final path is, and there can be any number of links in here that get you to the final path, and that may be actually more than Unicode string, which is the max limit. Really is around that. It's a short or a U short verse of bytes. So that's where the 32,000 ish comes in. But that's how it actually gets to the final path. And if you use the backslash question mark, the backslash period thing, that you get into the global space directly, is what that amounts to. And you have all sorts of things. You see there's tons and tons in here, and this is just a virtual machine that's brand new and cleaned up. One of the things that's notable is UNC, and that's device mop is the device for that. Every UNC gets turned into this. That's another special behavior that happens, right? So when the normalization happens in Windows, it'll actually go and take your, like if you have a server share, it'll take that / and turn it into / UNC /server share. And that way it gets routed to the right device that actually takes that. Pipes is in here as well. So you can see there's pipe. It's named pipe is the device for that. And a whole slew of other things, including things to get directly at the volumes and stuff like that. One of the other special ones in here is that there's actually a link called global and global root. Global root it says it has nothing in it. It's a symbolic link. That means root. So if you hit global root, you get back out to here, right? So you get back out to the root path, and then you can go in directly. So you could do from a Win32 app, which everybody does unless they're writing drivers. You would do / global root, and then device, and so on and so forth. And you can access any of the other objects that way. Opening a file handle is obviously going to only work with things that normally allow you to open a file handle. So create file only works for the appropriate things in there, but all the other objects are in there as well, security objects, and everything in Windows goes through here that has any sort of security model associated with it. But this is PowerShell, and they have turned on the behavior for because 4.6.2 is in the latest builds, right? So Windows. That's why I brought this up.
So on this one, you can probably bump up the font size.
So when I will, assuming I know how to do this, properties, font.
Yeah.
So, and I also talk about this on my blog as well, and we can put the links up there for that, about like how you can specifically turn on and off the behaviors. As of this particular build, it's part of PowerShell. They're doing it for you, so you don't have to do this. But this is something you couldn't do before. Here I am looking at C:\/ using the extended syntax. .NET would normally throw here. Fortunately, PowerShell is a very well written .NET app. It lets .NET do most everything, so it picks up this behavior. In a prior post, I'd shown how to actually turn this on even before they had done this, and that's using config files and the like. You have the ability to opt into it, and that's one thing I didn't talk about yet. But these changes are behind compatibility switches because they are, breaking in theory. The odds of it breaking are pretty slim, but still, being desktop, we err on the side of caution. So to get the new behaviors in 4.6.2, you either have to target 4.6.2 or explicitly opt in to these compatibility switches, which there are two of them. One of them is the one switch is to enable the new normalization behavior, and that allows you to do these question mark things and so on and so forth. The other one is to not block at max path anymore. So as a compatibility thing for people running the desktop, if you target 4.6.2 and for some reason you have some sort of problem around, or you want to still block paths that are over 260 characters the old way, right? Having .NET throw right up front, basically. Then you can opt into this compatibility switch, even if you are targeting 4.6.2 to get the old behavior of throwing, but still allow access to the extended paths.
So where are those switches?
They're in the app context. So
okay.
You can programmatically do that. A little tricky to do because this happens really early in the startup of the framework. Access to these particular switches. They're cached, and because you do just about anything, you're going to end up hitting path get full path. If you don't do it via the config file, which is the other mechanism to go in and do that, then there's a possibility you can get to the point where it's stuck in its default behavior. So the config file is the prescribed way to do it for this. We've been making changes, looking at making changes going beyond 4.6.2 to make this a little bit easier to use.
So what's a specific case where you'd want to use that compatibility switch? Because it's in cases where you relied on the passes.
So let's say you had a native component that was part of your solution, right? And it just did not handle the long paths. Now,
you know that it won't be able to handle it, so
yeah.
you want to fail earlier.
You want to throw normally. So like, if and when Windows removes that 260 character limitation, right, then you would want it to be still throwing the same way. And Windows is also looking at compatibility things, why people see the switches and stuff, so it'll be an opt-in sort of thing. But with .NET, we're saying like, all right, if you're targeting 4.6.2, we're going to give you all the new behaviors by default, but you still have the ability to go back to the more compatible way.
That makes sense. Okay.
We've had a lot of talks, incidentally, because you're talking about this compatibility thing. The odds of something like falling over in a way that like is a security related problem is actually pretty slim. And this is one thing that people are pretty concerned about. But every Win32 API actually takes the size of the buffer when you're actually going and passing paths back and forth. So if you were missizing the buffer when you're calling, you have an existing security problem that you need to look at anyway. But which hopefully we don't have. But there are still mechanisms just to be cautious, right? Allow people to have that opportunity if they do find some sort of compatibility problem. So far, we haven't found any internally, but obviously the .NET ecosystem is huge, and the Windows ecosystem is huge as well. So those options are there.
Okay.
In the PowerShell thing, it's the idea to use the lit or literal. It just didn't use the entire one to actually use this, because normally PowerShell thinks that tries to do something with that path. Some of the APIs do that, some don't. But like if I go out, I'm going to use like old crappy behavior. Let's try that. Make a test directory, right? So, I won't show you there, but like this won't work because we'll pull it off, right? But if I did this with the command prompt, this is just like they're trimming it off. But if I go into the command shell and I did md foo like this, it would actually allow you to create it with the trailing space, and we wouldn't be able to get a hold of it. But since we aren't scaling, right, I won't like throw people through this. But here's one that you couldn't do before. If I do this, like, oh no, it's already there. Well, no, it's not. But like, this is the normalization thing, taking that period off, right? This is the Windows pulling the period off the end of it. But I don't think I have to do literal with this one, but let's see. This is, pulling it into the POSIX compatible mode, right? So skipping the normalization. Let's see, we did test. True. So there you go. Now, if I look at this, you'll see there's both of them. And normally I can't get in here, right? because again, there's that normalization from Windows happening again. A little weirdness there in the what it shows you, but like you're unblocked now. So like people writing scripts are like you run across the problem once, you realize, oh, okay, well, you know, maybe if I put the extended syntax on everything, then it'll always work, and I won't have this, like, I have some random test file that generates random things, and like every now and then I have to go and figure out how I'm going to delete my temp folder because I can't get it to work anymore, right? Because like something has happened by some random program and I can't delete in there anymore because it's dropped something in with a trailing period or a trailing space. And now these things are open. The other thing that comes with this, and this is something that's kind of fun, is that you can access alternate streams. So I don't know if you know about this or not. But
yeah, I do. They are so rarely used.
Yeah, they are pretty rare. Yeah. But like, this is one thing too where you were stuck, right? Like,
it's actually a feature that I would have liked to use several times, but it's so obscure.
Well, now you can use it in .NET. You know, when you're doing the
just to explain what it is, in Windows you can actually associate several streams to a single file. Yeah. So in theory you could stuck some additional metadata or whatever.
And it's actually, Windows actually uses this. Like when you download stuff from the internet, right, and you get the thing where it's like, oh, well, you know, this was downloaded from the internet. You really want to do this? It actually creates another stream on it. That's how it identifies those ones, you know. So if you were to like look at the streams and list them, you'd see that that thing was on there for the ones that you downloaded. When you click on the box to make that go away, right, then it removes that stream. I don't do it everywhere because it is so unusual and people aren't used to it. So when you go into the question mark syntax, that's when we allow it. So
another reason not to use them is that as soon as you copy the file to a Mac, for example, it just disappears.
Yeah, it's an NTFS thing. Yeah. So, yeah, but it's for Windows specific things, it's useful in some cases. And again, it was someplace where you were blocked if somebody else was using them. So that is only available if you're using the question mark syntax, because then we don't do any normalization or checks, or the period syntax will work as well. Right. So if you're doing just C:, whatever, we still, to err more on the side of compatibility, we don't allow you to use that second colon. We still check for you're using a colon the way we traditionally think of using a colon, because that's how you actually access those other ones, incidentally, is that you put everything actually has multiple streams. It's just like there's one, and the default is a stream with no name on it, right? So it's like data, and there's multiple types, and data is the one that everybody thinks of as the normal thing. So you can actually access that. I won't show that here, but like I have some demos I'll do that on my blog and whatever, of like how you can mess with that. I think I showed one already, but this will unblock folks. So that again is part of this, like, well, you know, when we try to guess too much. So when you're using this question mark syntax in particular, the way we approach it is like, look, you know what you're doing. We're not gonna, like, we're hands off, right? We'll let it do what it's going to do, with modulo some of the things around limited trust and stuff like that I spoke about. And we're not going to, because through experience we found out that the more we try and second guess what's going on, the more we get it wrong, right? So, you know, I spent the past year like really deep diving into how all this stuff works. You know, I fortunately have access to Windows source code. I can look through all these things and like really nail down exactly what's going on. But I'm sure I missed something, right? And, if I tried to like codify, like what is legal and what isn't legal, someone else is going to find some other case where we're busted. Like who knows, mail slots does something weird and like nobody expected or understood, and somebody else is blocked, and you have to wait for a new version of .NET, or you have to p-invoke out yourself. And this is one of the problems that we have even internally for like moving forward. We've unblocked here, to allow long path scenarios to move forward finally. But because the other things have gotten in the way, various other layers on top, or applications, et cetera, have like hit some issue or whatever in .NET that they couldn't work around in .NET, so they started p-invoking themselves right out to the Windows stuff. And that makes moving forward more difficult. I was talking about how like PowerShell was depending on .NET, which had its problems in that you couldn't get access to these sorts of things before, but it was great because giving them the functionality, it was almost magic, right? They just had to say like, go ahead, do it. And like, they didn't have to go and hunt down a whole bunch of p-invokes and like and fix all those and shift over from one thing to the other and so on and so forth. So this is one of the things I really want people to take away, right? Is that like, what does it take to move forward? Well, if you aren't using p-invokes and you're using all managed code, long path stuff will come magically to you, right? It'll just work. As things get lit up in the operating system and whatever else, you'll get the implicit or the long paths with the old traditional C:\, paths without a problem. If you want to use the extended syntax yourself, then great, that works for you. And I'll give some prescriptive guidance around how you would utilize that safely around normalizing and so on and so forth. And outside of that, the real thing to do is like what we had to do for our runtime, and you can see some of the changes that were done in core CLR to support long paths, is you just have to stop, stack allocating max path. You have to like go through the APIs where you're passing paths to the p-invokes or native code when you're calling directly, and actually check the size, right? Check the size. Don't stack allocate anymore. Or in the case of like what we have a stack allocating string that shifts over to the heap if it gets too long, right? So, and that you can like even look at what was done there in Core CLR, since now we're open source, and utilize some of that stuff as well. And I'll provide links to what was done there and the changes that were done there. So
we'll put those in the description. Okay, so that's a great takeaway. Things will magically start working where they were failing before, and that's great. Are there any cases that people should be aware of where the magic won't work?
On desktop, there are the limitations, right? And this is where there are some places, like I said, I was not able, I took advantage of I knew the context, right, of everything that was going on inside of MS Core Lib, so that I could safely make the changes to allow the extended syntax, right? The question mark thing. And I was only able to do that for MS Core Lib. There are some things in System.io that live outside of MS Core Lib. I'll give you one example of something that does not work at the moment with extended paths, right? It'll still work with long paths, but not with this question mark thing. That would be File Watcher, which lives in a different assembly than MS Core Lib.
Okay, so but that will be only for the extended syntax. If you just use regular pathies, you're fine.
Yes.
Okay.
But and if you are using file IO permissions yourself, then file IO permissions has the same limits, right? You just can't use file IO permissions with extended paths. There was a internal shortcut that we used because we knew it was safe to do. I've given it thought since then, and my intent is to move that forward for 4.6.3, or whatever it ends up being, the next 4.6 next and beyond 4.6.2, to allow it for full trust all the time, and no gotchas around like, is it an MS Core Lib, or am I using file permissions myself. Probably not remove it for quite some time for in general for limited trust, right? Just because it's a much thornier problem. The normalizing is very difficult to do, well, both correctly and efficiently. That's the bigger part of the problem when you're going beyond the normal paths. So that would be the only other thing that you'd have to look at. If you're like, and even as .NET, we've stepped away from this, right? The whole deny thing, right, is like, that's depreciated right on the permissions, right? So like if you use file permissions deny, we depreciated that. Why? Because it's really hard to get that right? So why? Because you have to have canonicalize things to a point where like there is no alternative way to represent it, and that's extremely difficult to get right, even if you don't take in the question mark syntax. And then on top of that, if we were to try and normalize those things together, right, is this one equivalent to that one, right? That's one option, right? Just to look at it and like normalize it when we compare. That's hard to do without a lot of risk, because this stuff has been there a long time. It's kind of complicated, and we really don't want to break limited trust scenarios. That aspect, very difficult. The other one is like, well, if we try to normalize it to like, say, like the Windows object path as a canonical version of the path. Windows even has an API where you can get the final path name, right? You can get the canonical version of something. The trick there is that we don't know that the path exists, right? This is one of the things that the .NET stuff gives you, is that you can represent paths that don't exist yet. So what's the canonical version of something that you've given that doesn't exist on disk yet, right? Well, that involves some perf-related problems, right? And we have this already. Windows will implicitly, or not Windows, but .NET will implicitly expand the short file names for you. And this was all around the file IO permissions, is where this stuff was entering in. It's like we wanted to get that canonical version of that path. So if you had the tilde version of the file name, we would expand it for you, right? But we would expand it for you whether or not the full path existed, right? So we have to walk through the path that you've given, hoping to find something that actually exists, right? To actually do that. So like the same thing would happen here, but even more so in spades, right? Because you'd have to like go and like figure out like, all right, what's something that like gives me a path that like is actually representable by the object manager, right? Like, all right, I finally got something. All right, let me get the right canonical path out of that. So I'll make another call to get the thing out, and then put them together, and it's just a lot of work. If we get feedback from from people where this is a really critical scenario, of course, like then we can up the priority of working on it. But it's basically a big problem, and so it's unlikely to come soon. We'd love all these things to go away, period. And long term, we'd love to keep hacking away at these things and bringing more support into the desktop as well, like implicit support and that sort of thing as well, like the where you don't have to do the extended thing if you want to work on Windows 7 or whatever for long paths, as opposed to Windows vNext, where they enable long paths, right?
Okay. Well, thanks a lot. That was very interesting, and thanks also for the work in general. I think all .NET developers can be grateful for that work to happen, and we can all have a collective sigh of relief that those problems are behind us now.
Well, they're moving behind us.
Yeah. Well, yeah.
So yeah, the ecosystem is moving forward. .NET is moving forward. We'll continue to look at investing in desktop, on bringing the functionality we've done in core. But absolutely, we like very excited about it. it's been a long time coming.
Yeah.
And people have been fighting for this internally too for as long as I can remember. So it just, so many problems came in, and this was just the right time. You had somebody that was passionate about it, which is myself, and that was happened to look at it at the right time, and the open sourcing and like the depreciation of old operating systems. The list goes on and on and on, that everything finally got to the point where we're starting to tip over the edge. And, you know, we can move forward from here, and hopefully somebody will, you know, short paths, nobody remembers those too much anymore, right? Or the pain of like before Windows 95, when like you're like, oh, I can't think of any more creative ways to name my 8.3 file name. Hopefully people will be doing the same thing, you know, within the next few years of going like, I don't have to think about like my summer trip 2012, you know, the beach on Jansen Beach, you know, like oops, crap, I ran out of space in my OneDrive folder, right? You know, like that'll go away. So we're getting there.
Yep. Okay. Well, thanks again for being on the show today. And we'll see everyone again next week.
All right.
Bye, everyone.